In this video, I'm going to briefly describe three different methods for discharging objects. The first and most common way that we avoid objects becoming charged or we keep things safe from electricity is grounding. The idea is that we attach our object with a grounding wire to the earth. The earth is a large conductive mass. So if we take something, let's say for this example, with an excess of electrons, the excess electrons which want to repel can repel out through the grounding wire and spread themselves evenly over the whole earth. And while the earth itself is actually taking on a negative charge, it is so large that those charges spread out so much that that charge becomes ineffective. So if all three of these electrons left the material, then the material would go back to being neutral. And since the earth is so much bigger than the material, most of the excess electrons will just leave into the earth. Similarly, if we attached a positive object, we can imagine that extra electrons from the earth could be attracted into that positive object because they're attracted to that positive charge, and enough of them would eventually move into the object that it would become neutral, and as a result the positive charge would disappear. So either way, the earth either takes the extra electrons or gives some electrons, but since the earth is so big, the amount of exchanging that many electrons won't affect the overall charge of the earth. Water in the air. Humidity, or small water droplets in the air, can take away excess charges from materials. Say, for example, that you have a negative object and you have a neutral water molecule. Since the electrons in the material that's negative are repelling each other, they might go and join the water droplet, making it negative. Sort of a charging by contact idea. When they do that, they lower their overall charge. The original charge of this object would have been 2 plus minus 3, going to negative, or minus 4, sorry, going to minus 2. And if one of those electrons goes to the neutral water, then both this object, plus 2 minus 3 minus 1, and the water molecule will become negative 1, and so the charge is shared. This will eventually discharge the object. This is why electrostatic effects are typically very clearly viewed when the humidity in a region or an area is low, or when the air feels very dry, but are not particularly well observed when there's a lot of water in the air, because the particles can charge the water by air and as a result lower their overall charge, lowering or discharging them as they go. This is also why, say for example, if you have curly hair, that you find when it's dry outside, it gets particularly frizzy, because if it takes on a charge, there's no water in the air to take that charge away, and so it can have a little bit of static electricity. Grounding's a great idea, but it's not going to work for something like an airplane. Since airplanes are very high, obviously it's unfeasible for that to have them constantly connected to the earth. What they do instead is on the wing of an airplane, they add tiny points. The idea here is that as the metal wing moves through the air, it will pick up excess negative charges due to friction. If the airplane goes to land on the ground, those negative charges might try and jump to the earth in a spark of lightning. And if that happened, that could damage sensitive electrical equipment. So the idea here instead is if we have these tiny points, the electrons will get forced just through regular motion in the material into these small regions. In these small regions, at the point, the electrons will be forced very close together, and their energy will get quite high. What that means then is eventually they'll have the energy to force individual electrons straight out of the material because they're forced into such a small area. Their repulsive forces become large enough to eject them out of the material. In this way, planes use discharge. Ooh, what happened there? Planes use discharge at a point to keep from building up too many negative charges, and as a result, keep from developing a charge that's big enough to spark when the plane lands on the Earth, which could damage the electrical equipment or cause a dangerous situation. So by far the most common way we intentionally take charge away from materials is by grounding them or connecting them to the Earth. We can also recognize that water in the air, humidity, will naturally discharge objects over time. And discharge at a point is just a clever little solution for something like an airplane where it becomes impractical to ground the object.